Okay guys, so this is the calcium and phosphate homeostasis lecture. It's following the bone lecture, so some of the things we're going to talk about should be a little bit familiar to you, but now we're going to concentrate mostly on the hormones that affect calcium regulation within the body. So this lesson really goes hand in hand with the last one, and you could argue that they're basically inseparable. So first, a few introductory comments about calcium regulation. Here is a schematic which sort of very generally summarizes how calcium is regulated in your body and balanced. And it is regulated, by the way. Your body does try to keep the calcium concentration in the serum to as close to a constant level as it can. Very similar to the reflexes in the cardiovascular system. It isn't that you don't see variations in calcium, just like it isn't like you don't see variations in blood pressure. It's just that your body is tuned, for instance, when calcium drops, to bring calcium back up toward the normal value so that it will minimize the change. First of all, the three hormones that we're going to talk about are PTH, which along with vitamin D, as you know, affects the release of calcium from bone into the serum. Calcitonin also affects the release from the regulation of calcium in terms of its lysis in terms of making bone or breaking it down. And vitamin D, of course, as you know, is also involved here in terms of making sure that the calcium detection by the parathyroid is tuned and correct, so that the parathyroid sees and detects a normal calcium level and therefore will appropriately regulate PTH. So you guys pretty much already are familiar with that, but I'm going to take you through it again in a moment anyway. Vitamin D also is involved in calcium absorption in the intestine, and all three are to some extent affected in terms of the regulation of calcium by the kidney. So I've sort of mentioned the three organs now. We have three major sites that you have to worry about in terms of the action of these three hormones. One is bone, where the calcium is stored. One is the intestine, where calcium and phosphate are absorbed into the body, so dietary calcium and phosphate. And one is the kidneys, where calcium and phosphate are excreted in the urine. So this is our site of intake, dietary intake, absorption in the intestine. To a certain extent, you guys are probably familiar with that already from the food to fuel block. And then, of course, you lose calcium and phosphate to a certain extent through the feces and through the urine. And these two, if you're normal and you're at steady state, the loss from these two equals the intake through the diet. Okay, and then that keeps your serum calcium at a normal level, your bone calcium at a normal level. Of course, if there's an imbalance, that won't be the case. First thing to notice, we won't talk about it a whole lot, but when you talk about acid-base abnormalities, it may be something that you need to keep in mind. Half the calcium is actually bound to calcium plasma proteins and to anions. It's not free in the serum. And it's the free calcium in the serum that is going to be detected by your and it's going to cause the calcium regulation in your parathyroid. So your parathyroid is going to act upon the free serum calcium, okay? It will not know anything about calcium bound to proteins or anions, so only about half of this is actually free. Well, it turns out that the binding of calcium to the plasma proteins in particular is pH dependent. And the more alkaline the blood, the more calcium you have bound. And so that can alter this ratio. So you might actually have a normal amount of calcium, but if the pH is alkaline, there'll be less free calcium, and your parathyroid is going to think that there's less plasma calcium, and it's going to act appropriately in that case. Okay? So that's something to bear in mind. Oh, I just said that? Okay. So back to our schematic. One thing I want you to notice, calcium and phosphate, when they're combined, do precipitate and come out of solution. And in fact, that's part of the process of bone in a way. So you may wonder why that doesn't happen all the time. It's because, as a very, very general rule, these two are controlled in such a way that the calcium and the phosphate move in opposite directions. So that if your body is trying to get your serum calcium up, it will generally drop the phosphate. So the two don't necessarily co-vary, and it makes that precipitation less likely to happen inappropriately. I want to emphasize that that is general. We will have specific mechanisms where a hormone will tend to perhaps increase and decrease both together. However, in general, overall, your body is more or less tuned to make these vary inversely, okay? And I just offer that as a reason why you don't have calcium phosphate precipitating all over your body all the time, okay? Generally, we talk about the action on bone. We're talking about PTH and vitamin D acting pretty much to, on balance, break bone down. Vitamin D allows PTH to act appropriately. High PTH will result in more bone breakdown. Calcitonin, in general, does the opposite, okay? It causes calcium retention in bone, and the theory is that it's really trying to keep you from losing an excess amount of bone mass, and that's its primary purpose. Vitamin D, mostly involved in regulation of absorption of calcium and phosphate into the blood from dietary sources, so its primary action is in the intestine. Although we say PTH, calcitonin, and vitamin D affect the kidneys, the one probably to remember the most, I'm going to go through these one by one, is PTH. It has a major effect on the kidneys. It also causes an increase in vitamin D production in the kidneys, and that causes an increase in calcium as well. The effects of calcitonin, again, they're real, they're there, you should remember them and you should know them, but they're not very significant relative to PTH, okay? So let's talk about PTH, okay? We'll talk about PTH in this lecture, then we'll do calcitonin and vitamin D in the next. And perhaps there'll only be 2 lessons, we'll see how that goes. PTH, parathyroid hormone, as you might guess, secreted by the parathyroid glands in response to decreased plasma calcium. So your plasma calcium goes down for some reason. Your body says, we need to get that back up. It does that largely through the auspices of increasing parathyroid hormone. So this is a graph that you should remember. In general, as plasma calcium goes down, serum levels of PTH go up because the body is trying to get those serum levels back toward normal. And increasing PTH is a very, very major way in which it does that, okay? Calcitonin does the opposite, as you can see, so they act inversely, or they act together, and we'll talk about calcitonin in a later video here. So here is a quick summary of how PTH acts in the body to try to bring that serum calcium back up. It acts in some way on all 3 of those organs that I showed you earlier. Of course, it increases resorption in bone. You guys know that from the last lesson. It increases both the turnover of bone, and it increases resorption of bone, meaning osteolysis, and that causes an increase in calcium and phosphate release, okay? It acts upon the kidneys to increase phosphate excretion, that is phosphate loss in the urine, and decrease calcium excretion, meaning it will increase the retention of calcium, okay? In the kidney, it will decrease loss in the urine, so that is another way that you bring the calcium level back up. The effect on the intestines is indirect, not direct, through vitamin D, because as we'll find out in a moment, PTH stimulates the production of the active form of vitamin D. And so through vitamin D, it increases calcium and phosphate absorption in the intestines. However, that is indirect through vitamin D. So here's an experiment. What you see on top are the serum calcium and phosphate. This is the reabsorption of phosphate, which I'll talk about in a moment, by the kidneys, tubular reabsorption. And this is urinary calcium, calcium in the urine, urinary hydroxyproline, that is a byproduct of breakdown of the bone matrix. And this is in the urine, so it's excretion, okay? So in this experiment, they give PTH exogenously sometime between this day 1 and day 2. You can see the blue dashed arrow here. And they stop giving it at this dashed arrow here. So you see immediately what the effect on calcium and phosphate is. Serum calcium rises until the PTH is withdrawn, and then it falls back toward normal. Serum phosphate in the blood goes down, and then goes back toward normal when the PTH is withdrawn and the excess PTH goes away, okay? The urine calcium, there's an effect on the urinary calcium almost immediately. Okay, here's our serum. Right here, you can see we go from a level of, let's say, about just less than 100 to a level of about 20 or 10 here. Okay, so the urinary calcium drops almost immediately because of PTH's effect on the kidney. Okay, so what the kidney is doing is it's reabsorbing calcium. We're going to talk about that in a moment. And it's not allowing it to be excreted in the urine. It's retaining it to bring that serum calcium up. And you can see that in this drop here. Now you will note that the urinary calcium gradually rises after that. And that's because of the effects of PTH on bone and the fact that you're liberating calcium from the bone. So as you liberate calcium, you bring that calcium level back up in the urine. That does not mean that your kidneys are still not working to retain calcium and bring your serum level of calcium up. It just means that because you've increased the amount of calcium in the serum so much, you're filtering a bunch of it. So, and notice that the hydroxyproline goes up as well as the bone breakdown goes up. That's from breakdown of the matrix. So here is how the kidney works very, very briefly. The serum is filtered into this kidney tubule here, and it goes through the kidneys. And as it goes, as this tubular fluid goes through the kidneys, eventually it becomes urine at the end. And as it goes, what you do is you filter plasma as it is, and then you start reabsorbing things. And in the proximal tubule, you reabsorb phosphate. In the distal tubule, you reabsorb calcium. And so the more calcium you reabsorb, the more you're keeping in your serum. The more phosphate you reabsorb, the more you're keeping in your serum. So what does PTH do? It acts to increase cyclic AMP in both areas. In the proximal tubule, when you increase the cyclic AMP, you block phosphate reabsorption and you increase the loss of phosphate in the urine because you're not bringing it back into the body. When PTH acts upon the distal convoluted tubule, the CAMP still goes up. But in this case, what it does is it acts on this calcium channel, and what it does is it causes an increase in calcium reabsorption. And so your serum calcium will go up, your serum phosphate will not. It will actually go down as you use more phosphate. And that's pretty much all you need to know about the kidneys. Okay, we're going to talk about that in the fall of your second year. But in general, this is how the kidneys work: filter and then reabsorb, and these are the actions of PTH on that reabsorption. The effect on bone, as you guys will probably remember, bone turnover is the action by which osteoclasts come in, break down bone, and then about 2 weeks later a switch is flipped and osteoblasts come in and start laying bone back down. PTH and indirectly vitamin D cause increased production of osteoblasts, but that, through the auspices of macrophage stimulating factor and receptor activator of NF-kappa B ligand, so RANK-L, henceforth known as RANK-L. These two things act to increase the production and activity of osteoclasts. On balance, high PTH causes the osteoclast to be more active, and you get a net breakdown of bone. That's reviewed from the last lesson. And then finally, this is the action of PTH on the production of vitamin D. It acts in the kidney through this enzyme, proximal tubule 1 hydroxylase, to convert 25-hydroxyvitamin D to 1,25-hydroxyvitamin D. That is the active form of vitamin D, as we'll talk about in the next video, and that increases GI absorption of calcium, and you get increased absorption of phosphate as well.